possible, it doesn't mean they are the same likely, yes?
Sure, but see, this is an assumption. So now we are working with what we can test. So we can put we will put the assumptions. For example, when we are talking about a coin, let's say the coin has no corner to become like border to become easy for you understand. So we have two sides. If we don't put assumption, it's 50% to one and 50% to another. But let's say you start to study, start to analyze the coin, then you realize the top bottom is heavier. So now the chance increase to one side and decrease to the exactly. But this can be done only after analyzation. So you can just say, oh, like the bottom side have 60%. No, it doesn't. Why? Because you didn't analyze.
Okay, but the same, you cannot say that because there are two options, there is 50-50. You cannot say this.
You actually, if you want to be reliable and consistent, you need to say that because you don't have previous evidence to put any weight in any of them. So example, if I have one coin that has two sides. Let me put here. One coin, two sides. Top and bottom. So how about I arrive here and I say the top has 70% of stay up. Is it correct? If I say that to you?
I mean, depending what kind of approach or what, I mean, depending on external conditions. So in a regular, without any external conditions, it's not correct.
But I don't know the conditions. That's what I'm saying. Now I am making assumption. I just arrived here and I said, oh, the like top side has 70% of chance to stand up. This is assumption. I can't do that because I don't have information. So since I don't have information, the possibilities are equal until I measure. When I measure, then the probabilities can increase to one side and decrease to the other. So again, if I come here and I say the top has 70% of stay up, then that's assumption. And science doesn't work with assumption. We work with something that we can measure, we can test, right? So that's the problem of a lot of people. They make assumption. They don't use science. So see, I am telling to you that the intention, the universe was created by intention is 50%. And the universe not created by intention is 50%. Why? Because for now, we don't have any evidence.
We do have evidence because we live in the universe. So obviously, we don't have evidence.
What do you mean?
I mean, if you live in the evidence, so you have some sort of evidence, like how the universe looks like, and you might try to understand whether there is any, or you see any intention or not. So how can you say that you don't have any evidence about the universe that we exist in?
Yeah,
so there is some evidence, yes?
Because I'm not talking what we already have. I'm talking about this moment. So until now, in this conversation, we didn't talk anything about creation. We didn't talk anything about the universe.
But you attempted to talk about creation because you assume some sort of intelligent creator. So you tried to do about creation.
I'm talking about this example, brother. So in this example, did I mention, so see, let me go even further to you. You agree with me that there is only two possibilities, intention and not intention. So why not intention has a higher probability than intention without any evidence? You don't have any evidence.
We have evidence.
No,
so
brother.
First,
yeah, but we will look the evidences. I'm saying no. In the topic that we are going to look. I will bring the evidences actually. But as we start the conversation, you are starting the conversation. You are not showing the evidence. We didn't talk about those evidences. So imagine that you wake up now in the universe. Then why you will give more evidence to no intention than intention? Why?
But I didn't say anything like this. I said that it's not 50-50, or that you should not assume that it's 50-50. I didn't say that which one is more.
So why you give more to one?
I didn't. I mean, because it's not like, I mean, there are evidences supporting one of those theories. So I mean, it's not
Brother,
like that there are equal evidences. So I
brother,
mean, I don't say I choose more. I say that we live in the reality that can shift the probability into one side.
but brother, again, imagine you wake up now in the universe, you don't have any information. You don't have any information. You woke up now. Why would you give more weight to non-intention than intention? That's my question.
I didn't say that I would do in any side. I am telling you. I'm telling you that your example is not like a toss of the coin, because toss of the coin is purely random, but this is not.
You don't know if it's not. That's what I'm saying. You just wake up. So let's say you were born now, and we are having this conversation now. We don't know about evidences. We just have, or the universe was created by intention. We are analyzing the universe, right? Or it was created by intention or not intention. My question is, why are you giving weight to one more than the other if you don't have any previous information? Because you just,
Because I live in the reality where I do have information, and I do not live in the theoretical reality that you are presenting.
brother, but I'm telling to you, if we will talk about the evidences, wait, we will get there. But I'm talking if, say, pay attention. If you were born now, then you have those two possibilities. You have, or the universe was created with intention or not intention. So, with both two possibilities, do you agree with me that without any further evidence, without any further information, if you are honest, you need to give 50 to one and 50 to other?
I think so, yeah.
Yeah, you see, brother, that's my point. I'm not trying to say wrong, but now I go to your point. As we start to look the evidences, and you can bring me your evidences, the weight change. So, example, I call it the balance of probability. So, example, uh, let me show you. So, intention 50% and no intention 50%. So, let's say you start to analyze the universe and you start to realize life is like, you start to discover a lot of evidences that the universe was created not by intention. It was created randomly, so no intention in it. Then you you add the probability that you get into the no intention. So example, the no intention goes to 99 and the intention goes to 0.1. So now the things has changed. Why it has changed? Because now you are putting evidences of your research, of your study. That's how probability works. So I am welcoming you for we to look at the universe now and to use the probability to see if the universe was made with intention, if there is intention in the universe, or if there is no intention. But even if there is intention, it doesn't mean it was the Christian God. It doesn't mean it was the Jewish God. It just means the universe was created with intention. Okay?
Yeah, but maybe let's involve other guys, because it's not only between us. So
Yeah, I agree with you. That's all. That's what I'm saying. So, even if we get to the result that intention, the universe was created with intention, it doesn't mean it was the Christian God. But my first goal is to show to you that the universe was created with intention. And this intention will lead us to a very beautiful being that we call God. So, if you want now, I can share to you how the probability of this intention in the universe. So, example, Do you know the like okay. So do you know if the Earth get 4 times further from the place that it's now, life cannot exist? 4 times. Earth equal four
You
times.
mean the life that it is right now? Different life could exist. Yes.
Yeah, but we are talking about this life. Because then again you are making assumption. If you say, oh, maybe other life exists, okay, but we don't have other life. We are talking about this life. Is this life
No,
in
I mean
Earth?
we do have other life. I mean the life that existed
Where?
before was somehow other life. So I mean the life that existed like 2 billion years ago, 3 billion years ago, existed in different conditions, but it was life. So
Which
the conditions on the planet Earth, which was located on the similar distance 2 or 3 billion years ago, were very much different than what we have right now. And the life was there. So we had life with other conditions, which we do not fully know, but we have examples.
no, brother.
So
Example.
those 3 or 2 billion years ago, the conditions were very much different or significantly different, and life was there.
You are making assumption, brother.
No, I'm not making assumption. Life was there. Is it assumption?
So you were there. You were seen.
No,
You
life was there
no. How do you know life was there?
because there are traces of life.
Where?
Like everywhere, like not everywhere. Like I recently read about those one in Australia. I have a paper with me, so I can tell you where. Oh, you ask where? Okay. Luckily, I have a paper, so I will tell you where. So
Yeah.
what? Do you seriously want to know where? So I have the paper. I am right now with me. So do you want the exact place or what?
So tell me.
Okay, if you want, obviously.
Yeah. And show me how those lives were different. How those lives were different from the lives of now.
I mean, how life was different. I mean, for sure, it was in different conditions. So it was different. I mean, and how was different? Like very much different. It was very simple life. So it was
So
different.
no, brother. You were not getting. So this simple life are made of carbon or no? Because all the life that we know are made of carbon. So when you
Okay,
say
but
when you say different, we are not talking about characteristics because all
okay,
the life,
but I mean, there were different conditions, like very much different conditions, and life was there. So if you assume that those like four or like how many they say said 4 times is not like the conditions for the current life. So I'm saying that in the past, life was present in different conditions. Yes.
example.
So, so you cannot assume that I am like making any assumption. I'm saying that if this distance changed not rapidly, but within millions of years, so the life could still be there. So it's not like that if the difference is 4 times, it would disappear. It would disappear if it happened 4 times different at once. But if it happened within billions of years, the life could still exist.
But you are making assumption.
No, I'm not making assumption. I'm telling you are making assumption about that in that 4 times from sun it would not exist. So that's your assumption.
No. That's not assumption. Do
That's
you
the
know why?
assumption.
No, do you know why that's not assumption? Because
I don't know.
example, okay, all life is made of what? What all life is made from?
I mean, there are a few at least things.
No, brother, all life is made of carbon. So all life, that's why if you burn every life, it became black because the black is the carbon. So all the life is made of carbon, and we know that carbon cannot get together. It cannot create chains in a specific temperature. So example, if the temperature is too high, the carbon cannot produce chain to create those carbon beings. So it could work, but if you change the carbon to silicon, or I don't know, to gold, who knows?
Okay, so
Maybe
you
it
mean
can.
where carbon cannot exist? Where do you mean? Or in which conditions? Like what kind of conditions you refer to that carbons cannot exist?
Okay, so let's go to this way. After vapor, what does atoms became?
Like, what do you mean?
After the vapor state. What after water, brother, and after vapor, what does atoms became?
After water? What do you mean? What do you mean after water? Ah, it's gas. Yes, you mean that's what you mean, yeah?
And after gas?
I mean, there is state liquid, gas, and stable state, and also something between. Also, there is, yeah. So what do you mean?
Yeah, after gas, after vapor, it became plasma. So you need example each material, let's say Mercurian. I don't know if this is right, but Mercurian in the normal temperature, it's liquid. So you cannot create a being from mercury in such range of temperature because it would melt. So example, the good material to make humans or any animal was carbon. It is the sixth element of the periodic table because that's very stable.
Yeah, but carbon is present in many different conditions, much further and much closer to the sun as well.
That's what I'm saying, brother. Carbon can be close to the sun, but if this is in a higher state, it cannot join. And if this cannot join, then you cannot create.
Okay, but you speak right now about the origin of joining. But if there is already life and the conditions or the planet is moving into direction, so the life is there already. So what do you mean by cannot join?
No, brother, I'm saying there is a limit. So example, okay, aluminium. Can you make a human of aluminium in temperatures higher than 600 degree? Can you make?
I mean, I would say, I'm guessing, based on my guess, I would say no.
Can you make?
Okay, so I would say no. My answer would be no.
Yeah, why?
I mean, aluminium, as I understand, we are not built of aluminium. So.
Yeah, but
so that's first of all.
Sure, but like that's what I'm saying. Aluminium is no. How can I say to you? Like in elementary states, it's not so much different of carbon. The difference is in protons and neutron. So aluminium.
Okay, but why do you refer, like, what's wrong if, let's say, we are 4 times further? So what's wrong with the carbon? That's what you should explain. That's what I don't understand.
Yeah. So what I'm trying to understand to you is carbon has a temperature, and if you pass this temperature, if you go too higher, then you cannot make life. If you go too lower, you can't make life. So it have a standard. Okay,
so you are right now referring to temperature, but distance from a sun and temperature is different because the temperature can be different. It's not only dependent on the distance of the sun. So why are you referring the distance of the sun? The temperature is not solely dependent on the distance.
I know.
So why are you referring right now to the 4 times from here or something like this? And you are referring to temperature.
Very simple, brother, because example, why there is no life in Mercury?
I mean, whether there is no life somewhere else, we don't know, if we want to be honest. So there is no confirmed life there, yes?
Okay, let me go further. Why cannot, now I'm not making assumption, I make a scientific claim. Why cannot exist life in Mercury?
I feel that the life can exist in Mercury.
No, it can. Do you know why?
It can.
No, it can't, brother, because
it can.
Wow. So you are not getting, brother. Aluminium melts.
Okay, but do you know that on Mercury there is something like between the hot side and between the cold side, there is some line between. So even if you assume that life cannot exist, so there is the line between the hot and between the cold. Yes?
Yeah. And
so why do you assume that life cannot be there?
Very simple. So if we study both sides, example, the hot side is too higher to make carbon stable to create life. Yeah, like even our friend here answered haptozone. So it's very clear, brother, like every scientist will talk about it, but I will go further with you. So if you have higher states of temperature, the carbons they cannot get together and life cannot form in that state.
Yeah,
So
but
if life,
you are still speaking about temperature, but you are referring to the distance of the. Okay, so temperature. Okay, so it's not. It can be 5 times farther, but the temperature can be still the same. So why are you referring to the temperature? The temperature does not depend how far the planet is. Yes, and also the temperatures can be different on the planet, and also below the ground, the temperature can be different as well. So why are you referring to temperature?
so what, okay, let's forget the sun. If there is no sun, what's the temperature of a planet?
I mean, it depends on other factors, on the source of energy, whether there is source of energy. There are different sources of energy, yeah?
Example.
Like the tectonics, yeah? For example, radiation. Oh, radiation is one of the examples. If there are radioactive substances, they produce the temperature, yeah? Energy and temperature. Yeah?
From where these radiations are coming, brother?
From radioactive substances.
No, actually, no, brother, because radioactive substance, they are very unstable. And see, even the radioactive substance does not produce heat.
They produce.
No, it doesn't.
I mean, yes, they do. They do.
No, no, brother, it doesn't. What radioactive substance does is when you get the critical limits, okay, when you get the critical limits, then it releases a lot of energy, and then some scientists can get like some part of this energy, or you can use example some radioactive substance they emit alpha particle, so you can how can I say, you can make those alpha particle hit some substance that will hit this substance, but it doesn't produce heat by its own.
Okay, I have another example, like how they call it. I mean, the moons of the Jupiter, they do take energy from the being squeezed and like energy, like I'm not sure what's the language is, but the moons, for example, of the Jupiter, they take energy from the, I'm not sure how it called it, tectonics or how this is. So they do not receive heat directly, but let me Google this. So I have this. So they take energy from, how do you call it? Let me Google this because I don't know the word.
You can tell. But okay, brother, I try to make it even more simple. Let's go in this way. So telling the life that exists now, life, can it exist in 100 degree, any life that we know, like let's say any, I will put this, any life that we know can exist in 200 degrees, any life, even in the past, any life that humans ever saw, can it exist in 200 degree?
I don't think so.
Yeah, so it can. So if you get a planet too close to the sun and you reach this temperature, then life cannot exist in that planet.
Okay, but if you get too close and reach temperatures, so there are two assumptions, yes?
Yeah, if you get too close, and you, of course, you get the temperature if you are close to the sun.
No, I don't agree. I mean, the side of the Mercury that is always directed to the opposite side. Is it hot or not?
The opposite side is cold, but that's
No,
what
yeah. So it's like this. So how far is the opposite side from the sun? It's the same, or basically the same. Yes. And is it hot? No.
Brother, basically the same. But what I'm saying, okay, let's go clear to you.
So I mean, like, so it's very hot. It's very close to the sun, but it's not hot.
It's because you are going to the other point, brother. See, okay, the side that is pointing to the sun, can exist life in this side?
I mean, the light that we know cannot.
Okay, cannot, perfectly. So, and in the opposite side, can exist?
I'm not sure exactly what are the temperatures there, honestly.
Do you want
I think it's quite cold, so I don't think that it can.
Yeah, so that's what I was trying to tell all the time, brother. So if you get the sun too close and there is no rotation, if there is rotation, it's even worse, right? Because one, like this side will be very, very hot, and in the other day, the other side will be very hot. So you don't have life. So if you get any planet 30%, if you get the Earth actually 30% closer to the sun, then what is now life cannot exist.
No, I mean, I'm telling you.
My brother, you just.
I mean, how about atmosphere? I mean, do you understand that there's something like atmosphere? For example, if the planet has thick atmosphere, so the distance from the sun is not the only thing, yes? The atmosphere also matters. So the planet can be very close to the sun, but if it has thick or thin atmosphere, it changes the thing, yes?
Brother, it doesn't matter if you have more atmosphere. That's worse.
Yeah.
The temperature. That's worse. The temperature even increase higher, because now you have more atoms to the sun collide.
Okay, but so if there is a tight atmosphere, so the planet is, let's say, 5 times from the sun, and there is a tight atmosphere, so it can be enough hot there. So I mean,
No.
maybe it's not example for the 30 times closer, but it's good example for 30% further. Yes, because if there is even 50% further, and
Sure.
the atmosphere is tight, so the life still can be there. Yes, because the temperature, it does not only depends from the distance of from the star, as we said.
Sure, brother, but you see, you make about 20. I didn't said about 20. I said 30. So
okay, so it can be even 50. You know, the atmosphere. I'm telling you that that's not important how far the planet is. Basically, that's period.
Okay.
That's not the only condition. Yes.
Okay, so if the Earth get 30% closer to the sun, then the temperature that's now, would exist life? Yes or no?
I mean, depending on other conditions.
Let's say it has higher atmosphere. Would exist life?
I mean, most likely with higher, it would not. But it depends, honestly. It's not that simple. You are trying to put this simple, but the reality is that the reality is not that simple. I told you the source of energy is tidal heating. So if there is no sun, you can have real energy from tidal heating.
Brother, look what you said. I said, how about difficult? Like I said to you, if I get 30% closer, the Earth closer to the sun, even if have higher temperature, you said life cannot exist there, right?
I mean, do you also understand something like that the activity of the sun is different? I mean, is it something that you understand? The sun is not always the same active. That, for example, 2 billion years ago, the sun was active differently, and 2 billion years after would be active differently. Do you also accept this?
No.
So you speak about the current state of the sun or any state of the sun?
So what was the temperature of the sun 2 billion years ago?
I understand the sun is getting hotter, so the temperature of the sun 2 billion years ago was colder.
What was the temperature?
I mean, like, I don't know.
Yeah, so you are making assumption.
No, I'm not making assumption. I mean,
Let's search.
Okay, honestly, it's pointless to talk with you. I mean, you are making assumption.
Let's search for the sun 2 billion years ago. The same. It was almost the same. You have 100 degrees of a difference, almost nothing. You see? So the surface of the sun today is 5,500 degrees. And 2 billion years ago, it was just 300 degrees less, or even less, 100 degrees less, nothing. Oh, he goes. That's difficult. Yeah, it's complicated.